myself Shweta Shah. I am your instructor for the subject Computer Organization and Architecture. In this subject we have started Unit 7, that is Computer Arithmetic. In this unit we are going to see today the topic, that is BCD Adder. So let us start with the topic BCD Adder. The BCD representation is a class of binary encoding of a decimal number where each decimal digit is represented by a fixed number of bits. For example, 4 bits. Okay, so we are representing up to 0 to 9 numbers by using some bit pattern of 4 bit. 0, like for 0, 0, 0, 0, 0, for 1, 0, 0, 0, 1, for 2, 0, 0, 1, 0, and so on. Okay. So, BCD adder is a circuit that adds two BCD digits in a parallel and produces the sum digit in a BCD form. So, your numbers will be that you are adding will be also in the BCD format, and your result also should be in a BCD form. Okay. Since each input digit does not for this BCD number, it can't exceed than 9. So the output sum cannot be greater than 9. For example, if you consider the 9, 9 and 1, so your result will be like 90. So your sum cannot exceed than 90. Okay. Suppose we apply 2 BCD digit to the 4-bit binary adder. The adder will form sum in a binary and produce the result that may range from the 0 to 9. Okay, because our maximum number is 9. Okay, so that our sum will not exceed the 9 plus 9 plus, if we consider the previous carry as a 1. So our sum will not be greater than 90. So by adding this 4-bit two binary numbers, our sum will not be greater than 90. Okay, so it will be in a range of 0 to 90. It can be given like this. For example, if we consider this is the result of your summation. So it can be 0, 1, 2, 3, 4 up to 90. This result can be up to 90. Here our result can be 0, 1, 2, 3, 4 up to 90. It will not exceed than 90 because our maximum number is 9. Okay. So in this we can, if your binary sum is like possibilities of 19 these numbers, but we have to represent this number, or you can say this result, in form of BCD numbers only, because our numbers are in form of BCD and result should be also in form of BCD. Okay, so for this, if we consider this first 9, 0 to 9 bit or 0 to 9, then it is the same as a BCD. Okay, this is the format for the BCD. It is the result that can be generated. It can be 10, but in terms of BCD, this 10 will be like 0, 0, 0, 1, and after that 0, 0, 0. You have to use this 4-bit number 2, 1 for one 4-bit and 0 for another 4-bit. Similarly, if your result is 11, to represent it in terms of BCD, you have to represent 1 differently in terms of BCD and 1 differently in terms of BCD. Okay, and so on for all of this number from 10 onwards. So if we consider this 10 number, so our actual result which we get from the adder will be like 1010, or if it is 11, then it will be like 101, and so on. But we have to represent, this is not the proper binary BCD format. We have to represent it into terms of like this. If it is 10, we have to represent like this. 11, we have to represent like this. 11, 12, we have to represent it like this. Okay, we know that we can find out this by adding 6 into it, that we have learned in 3rd semester, that if it is your in the BCD addition, if your number is not in a proper format, then you have to add 6 into this number, and then you can get this proper number. Okay, so for that we have to decide when we have to add something, or when we have to add 6 into this number, so that we can get the actual BCD format. So for that we have to check this result. If it is for this, if we divide this result into 3 parts, so this is in a proper format. Okay, that is okay. Your binary number is same as your BCD number. Okay, for that onwards we have some changes. In that, if your carry is generated in addition, after addition, if your carry is generated, that means your number will be like 16, 17, 18, 19. Okay, that means you have to add 6 into it. Okay, so that is the one thing. If your carry or K flag is 1, then you have to add 6 into it. After that, you have to check this bit pattern. in this bit pattern, if you check for this, so for Z8 and Z4, if both of these are 1, for this case Z4 is 1, for this case Z8 is 1. But when both of this Z4 and Z8, that is your MSB, and after this MSB bit, that is your third bit, both of these bits are 1, that means your number is in invalid format. That means you have to add 6 into it. And another thing, if you check, then it will be like Z8 and Z2. Both of these are 1. Here Z8 is 1 for this 2 case, but for that 2 case Z2 is not 1. Okay, but this 10 and 11 number, you have Z8 and Z2 1. That means your condition can be like this. If your K flag is generated or your Z8 and Z4 from your addition result, Z8 and Z4 both are 1 at a time, or your Z8 and Z2 both are 1 at a time. So that you require to add 6 into this binary sum to convert into proper BCD format. Okay, so this is the basic thing that we require. We just basically require some adder circuit, and after this adder we have to add 6 if it is in invalid state. And for invalid state we have to check for the K flag, check for the ending of Z8 and Z4 and ending of Z8 and Z2. Okay, from this 3 thing, any of one thing is 1, then you have to add 6 into it. So let me see how we can design its circuit. So this can be like this. Here we have addend, augend, and it is the addition result, that is Z1, Z2, Z4 and Z8, and that we require to convert into BCD format, proper BCD format. And for that we require to check for the carry flag, or we require to Z8 and Z4's ending. If it is 1, then also we have to add 6 into it. And if it is Z4, if it is Z8 and Z2, if these two are 1, then also we have to add 1. Then also we have to add 6 into your result. So that we require 2 adder. Basically we require 2 adder. In first adder we will do the simple addition operation. In second adder we will do the addition of 6 with the result if required. And if requirement will depend upon carry and ending of Z8 in Z4 and ending of Z8 in Z2. Any of 3 is 1, that means we have to use over here OR gate. Any of this 3 is 1, we have to add 6 into it. If 1 is over here, that means you can consider it as a BCD carry and you will use over here. These two are already 0, 0, and for this one, if carry is 1, then you will get over here 1, 1. That means your full pattern for this 4-bit will be like 0, 1, 1, 0. That is 6. Okay, so you are adding 6 into this second adder. That is your output of your first adder, and 6. If it is 0, then you will get over here 0, 0, 0, 0. That means in second adder you are just adding 0. So by this way we can use this adder, BCD adder. Here we can summarize it like this. We can represent this binary numbers as a K, Z8, Z4, Z2 and Z1. K is the carry, subscript under Z represents the weight as 8, 4, second and 2 positions weight. That is your for BCD code. And when this binary number is equal to or less than or equal to 9, this corresponding BCD number is identical, therefore no conversion is needed. And the condition for correction in the output carry can be represented like this, as we have seen earlier, that boolean we can represent it in boolean function like C is equals to K, or Z8 Z4 ending, or Z8 Z2 ending. So we can represent it like this. And when it is greater than 9, this we can obtain this non-valid BCD representation, and for this opting we have to add 6 into it. And we can correct this by this circuit. We have to add 6 whenever incorrect number is there, and whenever it is correct we will add 0. So by this way our addition output we can got from this second adder. So this is our BCD adder. So we are ending our today's session over here. If you have any query, then you can contact me.